Hey, welcome back. In this video, we're going to continue with our animation blueprint, and we're going to take a look at the animation blueprint's event graph and see how we can use that event graph to get information from our character so that we can change our animation based on what's happening in the game. We're going to do this using state machines in our animation blueprint. So let's get started. Okay, so we've played around with hooking up various animations to the output pose. Let's go ahead and highlight these and delete them. We're now ready to start selecting which animation to play based on variables in the animation blueprint. And we can set those variables in our animation blueprint event graph. So let's head on over to that. Now we have this node called Event Blueprint Update Animation. This is very much like the tick function in our character blueprint. This event is fired off every frame of the game, and we even have a float for delta time. So we can update variables here on the animation blueprint every frame and use those variables to drive different animations. We're going to want a variable that we can check every frame to see if we should be in the walking animation versus the idle animation. Now we can add variables to the animation blueprint by going over to the left where we see variables and clicking the plus icon. Now it creates a new variable for me called newVar_0. I'd like to rename this variable to isMoving. Now next to the name, we see the data type for this variable. By default, it creates a Boolean for me. If I click on Boolean, it shows me some other data types I could choose for this variable, but Boolean is perfect for this variable. We can set it to true when we're moving and false if we're standing still. So let's set this variable. Just below the Event Blueprint Update Animation node, we see this try_get_pawn_owner. Now, if we accidentally deleted this try_get_pawn_owner, we can always get it back by right-clicking and typing try_get_pawn_owner. Now, this node returns a pawn object reference. Remember, our character is based on the pawn class. It's a child of that class. So try_get_pawn_owner is going to return the pawn that owns this animation asset. In our case, it's our character. Now, dragging off of the output node, we can access functions that exist on the pawn class, such as getVelocity. If we type getVelocity and select that, now we have a getVelocity node which returns a vector, and this vector represents our character's velocity. The direction of the vector represents the direction of our movement, and the magnitude represents our speed. If we're standing still, the magnitude of this vector will be 0. We can drag off of getVelocity, which is the vector data type, and we can access functions that exist on the vector data type. One of those functions is called vector length, and this node will return a float, which is the magnitude or length of this velocity vector. Now, if this magnitude is 0, we know our character is standing still, and if it's not 0, our character is moving. So we can check to see if this float is greater than 0. We do that by dragging off of the output pin and typing the greater than symbol and selecting greater. And now we get a greater than node. Now, a greater than node is a math node that takes two floats, and it checks to see if the first float is greater than the second float, and if so, it returns a Boolean value of true. If the first float is not greater than the second float, the output value will be false. Now, we can plug in a float value for the second input, or we can enter in a value in the text box. We want to check to see if vector length is greater than 0, so we're going to leave that at 0. And we're going to use this output value to set the value of our isMoving Boolean variable. Now we can get isMoving here in our event graph in several different ways. We can right-click and type isMoving, and we have two options, getIsMoving and setIsMoving. If we click getIsMoving, then we simply have a getter node that returns the value of isMoving. But if we want to set it, we could choose setIsMoving, and we now have a setter node which has input and output execution pins, as well as an input value for the value to set our variable to. This is the one we want. Now, there are a couple of shortcuts to get these getter and setter nodes. First, we could go over to the variables section, click and drag in is moving, and we have a pop-up that asks us if we want a get or a set node. Alternatively, we could hold the control key and click and drag in is moving, and we have a get node. And we can hold the alt key and drag in is moving, and we have a set node. So those are some shortcuts to getting these getter and setter nodes. Now we're going to take the output execution pin for event blueprint update animation and drag it in to set is moving. And now every single frame will be executing this set node. And the set node has an input for that Boolean value. It also has a checkbox. And if we check it, then we'll be setting the value of is moving to true. And if we uncheck it, we'll be setting it to false. But we want to plug in the value returned by this greater than comparison node. So we're going to click that and drag it on in. So now every single frame, we're checking our character's velocity. And if the length of that vector is 0, is moving will be false. And if it's greater than 0, is moving will be true. So we now have a Boolean variable here in our animation blueprint that we can use to drive our animation. So now that we have this is moving Boolean, let's go back into the anim graph. And here is where I'd like to play the different animations based on that Boolean value. Now to do that, we're going to create something called a state machine. Let's highlight these two animations and delete them, and right-click and type state machine, and we have the option add new state machine. A state machine can contain animation logic inside of it, and it has an output animation pose. So we're going to click that and drag it in to output pose. So whatever pose information is provided by this state machine, our character will adhere to that. Now click on where it says new state machine, and we're going to rename this to locomotion. Now let's double click on the locomotion state machine. And in here, we have the graph for our state machine. Now it has an entry node, and the entry node hooks up to states. And our state machine transitions between those states. So dragging off of the entry node and selecting add state, we can create a new state for our state machine. And we can rename this to idle. Now we can place animations inside of states. If we double click idle, we see that it has an output animation pose node. We're going to click on arms idle and drag that in and hook it in to the output animation pose. So here in the idle state, we're using the arms idle animation. Now we can go one level out of this state with this bar here at the top. We see that we're in our anim graph in the locomotion state machine inside the idle state. If we click on locomotion, we go back out and we're in the locomotion state machine. And by default, we go straight to the idle state, which plays our arms idle animation. Now one state can transition to another state. So we can create another state here for our walking animation. Now we could right-click and select add state and get a state and drag that animation inside the state, but there's a shortcut for that. Here inside the state machine, we can select our animation, in this case arms walk, and drag it in and drop it. And by default, a new state will be created with the same name as that animation. I'm going to rename it to walking. And if we double click walking, we'll enter that state and see that the arms walk animation that we just dragged in is here in the walking state and plugged up to output animation pose. Let's go back out into the locomotion state machine. Now we have two states, and by default we go straight into the idle state, but we can transition from idle to walking by creating a transition. We do that by clicking on the gray border from idle, dragging over to the gray border from walking, and releasing. And we now have a transition from idle to walking. And this little circle icon on the arrow is called a transition rule. We can double click that rule, and we see that it has a result node that takes a Boolean. So here is where we can place logic to determine whether or not we should transition from the idle to walking state. And we see here at the black bar in the top that we're in the idle to walking rule. Now, when should we transition from idle to walking? Well, that's why we created the is moving Boolean. We can drag that in here and select get is moving, and we can hook that up to the result node. Now, is moving is true or false based on whether or not we're actually moving. So when this variable is true, we will transition from the idle to the walking state. Now, we could also use logic inside of these rules. For example, if we wanted to check if isMoving is not true, we could drag off of isMoving and type not Boolean, and we see that there is a not Boolean node. And if we dragged this in to result, then if isMoving is true, then this not node will reverse that true value into a false. And that way we would transition from idle to walking if isMoving is not true, but that's the opposite of what we want. So we're going to use isMoving rather than not isMoving. And if we go back out into the locomotion state machine, we can hover over this rule and see a little pop-up that shows us the logic involved in deciding whether or not to transition from idle to walking. So let's compile this and save it and see how this works in the game. I'm going to go back to FPS level and hit play. Now I see that I'm in the idle animation, but if I click in the viewport and start moving, now the arms are swaying back and forth as if walking. Now this is great, except if I stop walking, my mesh is still in the walking animation. We're not transitioning back into the idle state. So we actually need a transition from the walking state back to the idle state. So that is going to be your challenge. You're going to add another transition, this time from the walking state back to the idle state. Now in the transition rule, you're going to use not isMoving. Remember, we could use not nodes to check to see if a variable is not true. So we want to transition from walking back to idle if isMoving is false, and that's where that not Boolean node comes in. So your state machine should look like this, with two arrows, one going from idle to walking and one going from walking back to idle. Pause the video and add the transition from walking to idle now. Okay, so we just need a transition from walking back to idle, so I can click and drag to create that arrow. And we need our transition rule, so I'm going to double click to enter that and right click to get isMoving. I'm going to use the getter. Now we want to use the not Boolean, so I'm going to drag off and type not Boolean and use that node and hook that up, and it's as simple as that. So now if isMoving is false, then we will transition from walking back to idle. Let's see how this works by compiling and going back and play testing. Now if I move, my arms are swaying back and forth as if walking, and if I stop, now the arms go back to the idle pose. This is great. So in summary, we added a state machine to our animation blueprint, and we're using that to choose which animation to play based on variables that we set in our animation blueprint event graph. And now we have walking and idle animations, and we switch between those based on whether or not the character is moving. Awesome job. I'll see you soon.